Module 15, the urinary system. Urine formation, the overall scheme. It's time to take an overview of the process of how urine is formed. The analogy to this process that your book uses is called the desk drawer analogy. Most desk drawers are full of all kinds of useful materials, things such as pens, pencils, staplers, and paper clips. But through use of the desk, unimportant materials such as gum wrappers, pencil shavings, and broken erasers make their way into the drawer. When you want to clean out that drawer, you can do it one of two ways. First, you could carefully pick out the unwanted items one at a time, working around the items that you want to keep. Or you could just dump out the entire drawer onto a table and then put the useful items back into it. The second method is the more efficient way to do it, and it's the same way that the kidneys use to clean out the blood. Blood plasma minus its proteins is dumped out into the nephron. So the material the blood wants to keep, along with the material it wants to get rid of, all moves into the nephron. Then the wanted items are put back into the blood. The unwanted material becomes urine. This process actually is composed of 4 steps. The first step is called filtration. It happens in the renal corpuscle. What happens is that fluid moves out of the blood's capillaries, or the glomerulus, and is filtered through a filtration membrane as it enters the lumen of the Bowman's capsule. As its name suggests, the membrane is porous, but will not allow the blood cells or proteins to pass through it. Thus, only the fluid of the blood, not the proteins or blood cells, will enter the nephron. We call the fluid that makes it here filtrate. Filtrate is blood plasma minus the proteins, filtered by the nephrons of the kidneys. So both wanted and unwanted materials are in the filtrate. It's just missing the blood cells and blood proteins. Filtrate makes it into the proximal tubule of the nephron. At this point, it's not urine yet. It takes the next 3 steps for it to become urine. The second step is called reabsorption. In this step, molecules move out of the nephrons and back to the blood. You can see here that there are lots of blood capillaries that are located alongside the nephron. So the useful molecules in the filtrate are reabsorbed across the wall of the nephron into those capillaries. Now, this process is a carefully controlled process to make sure that only the useful molecules are reabsorbed back into the blood, and even more importantly, taken in at their proper amounts. A good example of this is the concentration of sodium ions in the blood. You need to have sodium ions, but too many of them would disrupt the homeostasis of several body processes. But if there is too much sodium ion in the nephron, not all of it will be reabsorbed back into the blood. Only the proper level of sodium ions will be allowed. Thus, like the desk drawer analogy, the whole drawer is dumped out, or all the blood fluid is dumped out into the Bowman's capsule of the nephron. That is the filtration step. The nephron then begins to sort out the good materials, putting them back into the desk drawer, or in our case, the blood. That's the reabsorption step. The third step is secretion. This is the step where specific chemicals that are in the blood are removed from it and put into the nephron for excretion via the urine. To better understand this step, let's go back to our desk drawer analogy. Say you've dumped out the desk drawer onto the table, but you look into the drawer and you see a magnet that's stuck to the bottom. It has several paper clips sticking to it. In fact, it has way more paper clips than you need. So you have to reach into the drawer and manually remove the excess paper clips, putting them on the counter. This is like secretion. Any extra unwanted or harmful materials in the blood have to be intentionally removed or secreted. Not a lot of material is removed by secretion, but it's an important step to help keep homeostasis. The fourth step is water reabsorption. It's pretty much like the reabsorption in step 2, but it is a very complex process. Water moves into the nephron, and then the blood will reabsorb just the right quantity of water back into the blood. It leaves the rest to be removed in the urine. Now remember, you have 1.3 million nephrons in each kidney. These filtering, reabsorption, and secretion processes occur in each nephron. The average person has about 5 liters of blood, which moves through an entire circuit in the circulatory system every minute. Well, the blood flow through the kidneys is about 20% of that flow. So about a liter of blood can flow through the kidneys each minute. This is called the renal blood flow rate. Renal blood flow rate is the rate at which blood flows through the kidneys, which is 1 liter per minute. Water treatment plants, depending on their size, can treat an average of 227 million liters of water a day. You just learned that the nephrons of our kidneys can process 1 liter of blood every minute. That means that the kidneys in our bodies can process 1,400 liters each day. Though that sounds like a small amount in comparison, the kidneys do their job more efficiently in less proportional space than this large building behind me. Add to that our bodies do this process day in and day out without any conscious maintenance on our part. Our job is just to make sure we're getting a steady supply of nutrients to keep our kidneys healthy. Your urinary system is truly a masterpiece of engineering.